welcome back to our system design series. Today we are going to explore caching, a powerful technique used to enhance systems performance by temporarily storing copies of data in high-speed storage. Caching is one of the fundamental methods for improving response times, reducing latency, and making your application more efficient. And I would say, and like it most likely in your system design interview, you will have to use a cache for something because a cache have a huge benefit in improving the system performance and reduce the load on the database and overall make the application more scalable. So let's try to get take a quick example of a system to understand what is caching. So let's say that we have an e-commerce system, and in this system, the client will send a request to the server, for example, to get products, and the server will send the request to the DB, like read queries or something like that, and the DB will send the request back. So if the client wants to read a specific product, it will try to send a request to the server. The server will try to send a query to the database. If the product is there, database will send it back. Once the object is obtained, it will be sent back to the client, and yeah, that's it. So this process looks good. It works. It's efficient, but we try to think about, is there a way to make this process way more better? Can we improve the performance? Can we reduce the latency? This where caching come into play. So let's add caching and try to understand what caching is doing here basically. Caching is a technique used to temporarily store copies of data in high-speed storage layers, often in memory, to reduce the time it takes to access that data. When users or systems need to retrieve frequently accessed data or frequently requested data, they can get it from the cache directly, which is much faster than accessing the primary data store every time. By reducing the need to query the main database or perform expensive calculations repeatedly, caching helps improve overall system performance. Let's understand this more in this example. So what the caching will do in our system right now, when the client try to request the product, the server first will try to ask the cache, do you have this product? If the cache have the product, it will send the product back to the server, and the server will send it back to the client. And since the cache is in memory storage, it will serve it way more faster than the DB. If the cache doesn't have the product, the server will try to send the request, will try to query the product from the database, and the database will send it back. And once the server is obtained, it will save it in the cache and return it to the client. So it will save it in the cache to in future use. So when the client try to ask for that same product, it will get directly from the cache. So the primary goal of caching is to improve system performance by reducing latency, offloading the main data store, and providing faster data retrieval. Imagine a popular e-commerce website that gets thousands of requests per second for the same product information. And instead of hitting the database for each request, the data can be cached, significantly speeding up response times and reducing the load on that database. There are several common types of caching and caching strategies. Let's talk about the types first. After that, we talk about the strategies. And in today's video, I'll just talk on high levels of it. I will not be like take too deep dive. I will create a video for each one of them in the types and strategies so we understand it better. So right now, the first type will be the client side caching. Okay. This type of caching involves storing data on the client's devices, such as a browser's cache, for example, in Chrome, using browser cache all the time. This helps improve user experience by making websites load faster when users revisit them, since assets like images, CSS, or JavaScript already stored locally. The second type, we will have the server side caching. Okay. And server-side caching data is cached at the server level. This includes storing frequently accessed data in memory database like Redis or Memcache. Server-side caching is often used for database query results like API responses or maybe pre-computed views to reduce the time it takes to generate responses. Number three, we have a CDN or a content delivery network, the NN for the network. So CDNs are used to cache static content like images, videos, and scripts closer to the end by users storing them at edge locations around the world. This minimizes latency by delivering content from a server that is geographically closer to the user, reducing the time needed to load the content. Number four, we have the application level caching. Application level caching. So many web applications implement caching at the application level, where frequently used objects, calculations, or data are stored in memory during the runtime of the application. This is particularly useful for avoiding repeated computations of the same data. Next, we need to talk about some strategies. I will just go quite fast in them. We have write through cache, and I will talk about them in details. So in write through cache, data is written both is written to both the cache and the main database simultaneously. This ensures the data is the data in the cache is always consistent with the main data store. Write through cache is great for applications where data consistency is crucial, but it may come with performance trade-offs during write operations. Number two, we have write back, which can be said as lazy write cache. In a write back cache, data is written to the cache first, and the update to the main data store happens at later time. This approach improves write performance, but can risk data loss if the cache fails before the write to the main database is completed. And lastly, we have cache invalidation. So cache invalidation is a process of removing stale data from the cache when the underlying data changes. This is crucial part of maintaining the accuracy of cache data. Common invalidation strategies include time to live, where cache data is automatically removed after a certain period, or manual invalidations triggered by an update to the data, for example. So caching is incredible powerful tool and strategy, but it also comes with challenges, and one of the biggest challenges is cache consistency with the main database, ensuring that the data in the cache matches the data in the main data store. Cache misses are another considerations. They occur when requested data is not in the cache, which then requires a fallback to the primary data source, resulting in a slower responses to address cache misses. Systems often uses combinations of prefetching and adaptive caching to predict and store data that is likely to be requested soon. So I would say that's it for this video. We might take some some examples, but I guess I'd like to make the videos pretty easy, pretty smooth, and pretty fast. I don't want to make the video like 30 or 40 minutes long. I'm talking about the cache and why we use the cache and what is cache, and that's it. In the next videos, we will try to talk about the strategies and type of caches and how to fix the consistency problem in the cache and how to fix the cache miss and etc. So that's it for this video, and if you like the content, please make sure to subscribe and hit the notification bell so you'll never miss any video, and see you guys in future problems.